the rule for powers now. B is given by a raised to the power n, and now if there is an error in A, how do we calculate or estimate the error in B? So moving on from here, B plus minus delta B, be the error in B, equals A plus minus delta A to the power n, where delta A is the error in A. On both sides, what we do is we take B common here and we take A common here. We end up with B times 1 plus minus delta B by B. On the right hand side, A to the power n times 1 plus minus delta A by A raised to the power n. Since there was a power n here, on taking A common out here, we have A to the power n. Now, since B equals A to the power n, we have a cancellation and we end up with this equation. Delta A by A is a small quantity in comparison to 1, and therefore we can use binomial approximation. 1 plus x to the power n is approximately 1 plus nx. And after this, we end up cancelling the 1's on both sides, and we have delta B by B equals n times delta A by A. This then becomes our rule for powers. Now, let's take a simple example where we use this. A is the edge length of a cube, and it equals 8.00 plus minus 0.08 centimeter, 0.08 being the error in the edge length. The volume will now be a cube, of course, and since it's a cube, 8.00 whole cube gives us 5.12 times 10 to the power 2 centimeter cube. Now the error in this V and the error in A are related as per this rule in this manner. Delta V by V equals the power 3 times delta A by A, and delta V therefore is V times 3 delta A by A. V is substituted here, 3.08 by 8.00, and this is approximately 0.15 times 10 to the power 2, and volume therefore is reported as 5.12 plus minus 0.15 times 10 to the power 2 centimeter cube. Fairly simple calculation this. We'll take the opportunity now to make a calculation where we'll be using pretty much all the rules we have studied so far. And let's say we have a formula here where D is related with A, B and C in this manner. Percentage errors in A, B and C are given as 1, 0.5 and 2% respectively, and we have to work out the percentage error in D. Now delta D by D will be equal to, now remember, A cube is multiplied by B square and then there's a division by root C. So we'll be applying the rules for multiplication and division. And remember, in multiplication and division, the fractional errors are always added. So we'll be adding fractional errors here. Of course, fractional error in A cube plus fractional error in B cube plus fractional error in root C. Now fractional error in A cube will be 3 delta A by A, that's the power rule. Fractional error in B square is 2 delta B by B, and fractional error in root C is root C means C to the power half, and therefore the power is half here, half delta C by C. We can multiply both sides by 100 to get percentages. So on the left hand side now we have percentage error in D, and when these quantities are multiplied by 100, delta A by A times 100 is actually the percentage error in A, delta B by B times 100 is percentage error in B, and delta C by C times 100 is percentage error in C. Those percentage errors are given. We substitute those values. 3 times the percentage error in A, 2 times the percentage error in B, and half times the percentage error in C, and we end up with 5% error in D in this case, which pretty much sums up the series of videos in errors. The more complex cases of calculation of errors require the use of calculus, and those calculations we will be covering a little bit later on, once we've covered a little bit of elementary calculus in our videos. So there will be more on the calculation of errors, but only after we have learnt the use of a bit of calculus.